All right, now we have here a problem that deals with the electromagnetic spectrum of waves. Um, the first question gives you state one property of electromagnetic wave that is not common to other transverse waves. Well, I think that will be the ability to travel through vacuum. Okay, the EM spectrum is so unique that they can actually travel through vacuum. They don't need any particular medium in order for them to propagate. Okay. Next, we have here the whole spectrum, and you're asked to define and write down the wavelength for every specific wave within the spectrum. Now it says here wavelength is decreasing from A going to G. Let's now identify what are the values of your B, E, and F. B would now be your microwave. Okay. Your E most likely would be your ultraviolet. Okay. Then last one would be your X-ray. Now, how do we identify that? After the first one, which is radio, right? This is radio. Of course, that's gonna be considered as now your microwave, which is letter B. Now, right after the visible region, which is the visible light, you will have next would be your ultraviolet. That's why we have this UV. Now, of course, before the very last one, which is your gamma, you will have your X-ray. Okay. Now, in terms of the wavelength, what are the values for microwave? That's 10 to the negative 4 to 10 to the negative 1. Okay. For the ultraviolet, that's going to be 10 to the negative 7 to 10 to the negative 9. And for the X-ray, that's going to be 10 to the negative 9 to 10 to the negative 12. All right, let's now proceed with this question here. Calculate the frequency corresponding to a wavelength of 500 nanometers. Now, in these questions, you're going to be using the wave equation, which is V equals to N lambda. F lambda, I mean. Let's right here. V equals to F lambda. You're trying to find the F, make F as your subject of your equation. So that's F equals to V over lambda. V here would be the speed of light, which is 3.0 times 10 to the 8. While the wavelength would be 500 nano would be times 10 to the negative 9 meters. Okay? It's meters per second. Let's try to compute the value. This one gives you 6.0 times 10 to the 14 hertz. Okay? 6.0 times 10 to the 14 hertz. All right. What would now be the answer for this one, the last one? All the waves in the spectrum shown in figure 5.1 can be polarized. Explain the meaning of term polarized. Polarized means that actually it allows the wave to only move in one direction. What do I mean by that? Our EM waves are actually moving into separate directions, right? Transverse waves moves into the separate directions. One is the movement of the particle, okay? And one is the movement for the propagation of energy. In this case, we have two movements. Movement of the electric wave and movement of from the electric field, and the other one is movement of your magnetic field. So imagine it like this. One is moving like this, and the other one is moving like this. If you're gonna try to polarize it, it's either you only allow this one or you allow this line, one at a time. Okay, and as they propagate it, they are gonna be moving on one direction only. All right, that's what polarization or polarize